Ever wondered how to take sheet steel, pump it up and form it into a 2-stroke expansion pipe like this? Well, today I'm with Martin. He's got 20 years of experience doing this, a lot of tips and tricks, and the one for getting the ripples out of the belly, that just blew my mind. So, what are you going to show specifically today then, Martin?
Well, I'll go through the whole process from transferring the base design to the template, the shape, and cutting out the steel, forming the edges, welding, and then the important bit, which is pumping it up.
Okay.
And then how to transfer that into the finished article we see here. A lot of hammering.
A lot
of hammering.
Get ready for a lot of hammering, so yeah. So quickly before we start, only 10% of you are actually subscribed to this channel. The goal is to get to 15,000 subs before the end of the year. So if you're liking what we're doing and you're liking what you're seeing, then hit that subscribe button. Many thanks. So I'm here at Martin's. You can see these are his templates. So there's quite a few. How many templates do you reckon? RD200 DX. What have we got? A TZR 170. LCA. Oh, that is. Yamaha A pipe. Lambretta.
Yes, I've done a few 350 Lambrettas.
350 Lambrettas? Yeah, so there's a few years. How long have you been doing this then? How many years worth is it?
I started in about 2005, 2006.
Okay. Yeah.
Hydroforming.
Yeah.
And quite slow to start with.
So there's a good 20 years worth here then. What's your first pipe?
My TDR 250.
TDR 2. Oh, they're the I'll stick a picture in, but they go up over the top, don't they? The pipes.
Yes, but not being very good at curves.
Yeah.
Mine are underslung. So if you're on the TDR forum, you'll know about my underslung.
Okay.
So they were my first pipes.
But they work.
They do work.
Good.
Yes.
That's the key, isn't it? Oh, yeah. So we've got a template here. So what's this one for then?
Work out the design initially using EngMod.
Okay, so
2-stroke simulator.
So you're an advocate of EngMod 2T then?
It works for me.
Cool. It works for me as well.
The dimensions I work out on a centre line.
Yeah.
Which fits the bike.
Yeah.
This is gradually gets tweaked over the years and slight alterations through the process of making them. And then I work out the lengths every sort of 50 to 30 mil. Yeah. And work out the diameters. I allow for about 5 to 7%.
Okay.
Expansion.
Just expansion.
What happens is when it's blown up,
yeah,
it stretches the material.
Okay.
Which then causes it to expand from the width of the template.
Yeah.
So you allow for that.
Yeah.
There's a lot of pressure.
Yeah.
Up to about 800 psi.
800 psi. Cool.
So once that's mapped out.
Yep.
This gets placed onto usually a big sheet of steel.
I noticed you got a few back there. So what sort of steel is it? Just
mild steel.
Mild steel.
Generally about 0.9 mils. So once that's traced out, I always add extra on the end.
Okay. So what's that bit for then? So that's just.
So you use a ruler.
Yeah.
And just.
So
when you form it.
Yeah.
It's handy that you have extra length for the bits that you weld the ends to, so don't go round.
Right.
So you need a bit of leeway. Trusty tin snips.
How long you had those then? They look quite old.
A long time.
Yeah.
These have done well over a mile of cutting.
Miler. You've had your money's worth out of them.
Strong arms. So I always go on the, because obviously when you trace it out, the pen mark you want is on the inside of the, of the line. So then you can just go along.
We were chatting before because the spring's gone off here, isn't it? Yeah. Out of use.
But you get a technique.
Yeah.
By pushing it, it opens it up again.
Oh, I see.
Quite often I'd just do this on the floor.
Yeah?
Yeah. But my knees are getting old.
Yeah. When were you 16 then? What year were you 16?
1993. So I was born in 77.
We're the same age then?
Yeah.
What month?
January.
Oh, you're a bit older than me. I'm March.
Yeah, see, that's the difference. Well, that's the joy of hydroforming, is I can make a pipe in probably about a day.
Yeah. So, I was just asking Martin, how do you know? Because obviously, as we'll see, I guess when you inflate it later, these will change shape.
Yeah.
So it's just how do you actually get the profile then?
So using my jig frame as an example down here, I'd get a bit of wire, and I would bend this to the shape of the pipe that I need.
Yeah.
Obviously you get an idea. And then what I would do is lay this out onto a bit of paper.
Yeah.
And because I know with experience that the curves will always tighten,
yeah,
all I do is just unbend that a little bit. That's all I do.
So it's a kind of just a feel.
Yeah.
More artisan than anything making these.
And if it's a new design, quite often it's not quite right, but it's close enough.
Yeah.
If I know I'm going to keep doing them, I can tweak the pattern more exactly.
Yeah.
And then redraw out the template.
Yeah.
And, but I've been doing T-R pipes for so long that I have a centre line that works.
Yeah. Yeah.
And pipes have to do quite a complicated curve.
Yeah.
So you would still work that out with the wire. So for example, if you're doing a pipe that comes with long and then back out and back up.
Yeah.
You work it out in 3D like that.
Ah, right, yeah.
When you transfer that to paper, you would do one curve like that.
Yeah.
And then you would rotate and then do that curve so that it's in 2-dimensional.
Yes, so you're going from 3 to kind of 2.
Yeah, and then that one you would bend it over again and then do that curve. So that the idea is that once you've hydroformed it, you would cut it off at that point, and then you can rotate to the orientation to match
right.
the wire.
I'll go. So what's the next step then, Martin?
So you have the line at the edge of the template,
yeah.
which you have to scribe.
Okay.
Otherwise, in all the welding and manhandling, your pen mark will rub off.
Oh, I see. So it gives you a good guide of.
That's the cutting mark for later on. The next step is to start forming the edges.
It's going to be an expensive bit of equipment, I feel. Is it mold grips?
Mold grips.
So how do these?
So these are modified with a bit of steel.
Yeah.
On the lower jaw.
Yeah.
See, the profile is quite rounded.
Yeah.
And that, once it's clipped onto the steel,
yeah,
just fold it enough. If I demonstrate.
Cool. Right.
So you have to remember which side's in and out. The grooves on the top jaw.
Mm-hmm. So that one, I guess these here.
Yeah, that actually fits on quite neatly on the metal.
Oh, let me just get that fixed. So the corner of the metal's going into that first groove. So again, Martin, we're discussing this. Martin's, as I like, just I wouldn't say make do, but what's the word? Resourceful. So instead of getting a new vise that's got a twisty bit, swiveling plate, just take the bolt out.
The problem is that when you want to crimp or weld the outer edge, obviously you can't. The bench gets in the way.
Yeah.
So you can pivot that, and then it'll fit around the corner. And
just coming to the end now, and I guess welding next, I suppose.
Yeah. Well, we've got to straighten it first.
Ah, right.
When the edge is folded, it distorts the whole thing.
Oh yeah. Yeah, because it is. If I come back, you can sort of see it's. Yeah. Not straight.
Just press it flat. So when you do that, you end up with all these little kinks.
Oh yeah, yeah.
So we have to dress them out now.
Okay.
Next step is to start getting them together. So
yeah, this is quite fiddly. This is it, I guess.
One side up with a bit of wood.
Trusty bit of wood.
So you have your score mark one side.
Yep.
Score mark, it is there.
Yep.
So you can kind of feel when they're about right. And because the fold is about 45 degrees.
Yeah.
What you do is you can hammer straight down.
Yeah.
And that will form 45, but then it will bend down to be a butt weld.
Yeah.
So I only do a little bit at first because then you can double check the scribe marks.
Yeah.
And just the general alignment between the two. And then I'll turn the welder on.
The old, what is it? MIG-Mate.
MIG-Mate sit from 1997.
1997.
And I'll just put one tap plug there. and that starts holding them in the right position. Put that in, and just hold it in one hand.
Yeah.
And again, same thing.
So yeah, I see. So, and you can see now where Martin is kind of, that's like 45 degrees. So the initial bit, and now he's just hammered it down, and you see that it's pretty much 90 degrees where the two bits meet. And MIG welding. I've got my safety squint on. You done? And I guess
that's held
that's
it.
Just a few.
That's set the alignment.
Yeah.
So the next thing is, so you see when we've smoothed the fold over on the back of the guys, how you get a fairly good, as you hammer it down, you work your way along, so you would start welding. So you do about 4 to 5 inches at a time.
Yeah.
So normally it's quite handy to strike at about 45 degrees down both sides.
Yeah.
And then straight down just to finish. So if I
that way.
Yeah, and then a little bit that way.
Yeah.
And then straight down. Sometimes you get a little gap like that.
Okay.
So you can, that's when you hit it at a bit of an angle. If you keep hitting straight down, it will start bending back too far. Tighten it up. But then you weld up to that bit and basically just carry on.
Just keep going. Right.
So basically the next bit along.
Next bit, so
the next thing is to weld on the adapter for the pump.
yeah.
This is just a hydraulic fitting welded to steel tube.
Yeah.
So you put a garden tap on the end.
Okay, why is that then?
It's
Water the plants?
yes, you could do. It makes it so much easier to fill.
Oh, I guess because you're going to get an airlock,
If
isn't
that was
you?
a closed end,
Yeah.
how do you get the air out?
Yeah.
So you can get the water in.
Yeah, you'd get it trapped somewhere, wouldn't you? So
that's just a quick, easy solution, and that gets welded on the end.
Safety squint. Right, so you've got the old GT85.
Yes. So obviously because this is mild steel.
Yep.
And we're dealing with water.
Yep.
Rust.
Yeah.
So we might get a lot of leaks. So the answer is you just give it a bit of
GT85.
and then rub it with my trusty oily rag. The initial filling, but it makes it quicker to fill, so you can check for leaks. It's just getting the water back.
Oh, I'm not standing there. It's using a bit of gravity.
Yeah. Turn that off. And then you can check for leaks. Looks like we've got one somewhere over there.
Yeah, it's just there, isn't it?
Yeah.
So, done a couple of leak checks off camera, a couple of little bit of extra bits of weld.
Always on this bit.
Yeah, is that always the bit?
Weirdly, that's full of water. Next thing is to bleed it through, which is what you have your garden tap for. You give it a little
pump. Now, usually this would be done outside, but it's blowing a gale, so you won't be able to hear anything. So, so it's not quite standard.
There you go, that bled through. So the first stage, when you expand it, normally the fat bit will expand first.
Yeah.
And then the header bit will start expanding. And the problem is that if you pump it without clamping the fat bit, you end up with extra creases, and you can get creases along the outside of the joins. So what we do is we clamp it between 2 bits of wood.
Okay.
And that controls the speed at which it expands and gives you a bit more control, and you can start forming the seams a bit smoother, a bit sooner.
So just bits of wood and I guess G-clamps and...
Yeah. That's just loosely clamped, and then if we start pumping, this isn't a quick process.
So how long do you reckon then?
Don't get any leaks. These are normally done in about 35 to 40 minutes.
Okay.
Basically there's a lot of hammering to get the shape as smooth as possible.
Okay.
So we start clamping, you see it starts tightening the clamp. Because It's also a good time to check for leaks as well, which we might have a little one here.
So
even we've just got the barest initial pressure on. You can actually see, I don't know if you can see in the light.
Oh yeah,
starting to
yeah.
And you can see a little leak.
Oh yeah.
Joint.
Yeah.
But that's fine for the moment. What we'll do is keep going until that's
okay.
more obvious. So a bit more water. In fact, you can see that's starting to swell.
Yeah.
So then as that swells, we undo the G-clamps a couple of turns.
Okay.
And then we do another couple of pumps. And then do that a little bit. And this just stops the belly forming too soon. It just has a bit more control.
I can really see it now, sort of starting to form there.
So fairly early on, we will start smoothing the fold that we made for the to make the joint. As I pump it up, you can start to see it creasing, pulling in.
Yeah.
So as you release the pressure here, that will bend back out again.
Oh, okay.
But at some point it will reach, as the pressure goes up, it will reach its natural shape. So usually about this point,
yeah, I can see it moving now.
as that's got to that thickness.
Yeah, so what's that, a couple of inches?
Yeah, that's when I find it helpful to start smoothing this seam off.
So you just, so the kind of, that's the bit that we bent in.
Yeah. If you pumped it straight out, you would get a lot of creases in here. It's like trying to blow up a crisp packet. You end up with the creases around the side. It doesn't blow into a round ball. So I just use my trusty hammer, because there's at the moment about 100 psi in there.
Oh.
So then we can start. So this can often be a difficult bit on the outside of longer radiuses. So that's when you start smoothing the seam off already. So that started it on its way.
Yeah.
Same on the top.
Oh, I can see, yeah, you can see quite a defined line around there.
So if you get the lighting right, you can probably see the difference as I work through. That started on its way.
Yeah, so Mark was saying that the reason for the holes is, I guess you've not got one of those.
Yeah, the end bit fell off.
Ah,
I've carried on using the G-clamp, and it's just the pressure and the binding. It does the job.
Oh, you can really see that moving there. That was really... Yeah, so a little bit of a hole there.
And
then,
as the pressure increases, you get a real jet, and that makes it easy to spot where the hole is.
Yeah.
So what I do then is mark that with a pen, and we'll have to drain the water out, weld it up, fill it up, and then carry on.
Off again.
So we've got a little hole. It's still getting wider, and this is still a good time to keep on working on what can be the troublesome spot.
Yeah, yeah, I can feel it's smoother there, and then obviously this bit's not been hit yet.
That's not too bad. It's about getting that bit in. So that's quite simple at the moment. And we can do underneath as well. So you can see around it's always the longer curves. It starts distorting when sort of folding and turning in on itself, which is why the sooner you start forming that smoother, the better.
So rather than blowing it all up, then trying to deal with it, you get into it straight away and just tucking those in.
So you can feel you can start to see it's sort of starting to go.
Yeah.
So you can give that a roll.
So where we're at now then, Martin?
Well, we're about the limit of the clamp.
Oh yeah, that's not going to wind anymore, is it?
We have a hole at the top.
Yeah.
So what I will do now is take clamps off, drain it, weld the crack, and then it'll be from then on straight pumping, straight from the pump, the last bit of...
Cool.
There.
I guess, yeah, so it's sort of...
So yeah,
it's nice and smooth, isn't it?
angle you can see.
Yeah.
It's still got a long way to go yet.
So what are we there? Probably 3 inches across?
Yeah, 2.5, 3.
Yeah.
Right, I'll take that side to drain it.
Cool. Oh. So re-welded, and this is the final bit, I guess. Start of the final bit. I'm getting ahead of myself.
So again, as that gets pumped up, you can start to see this, the curves tighten.
Yeah.
And this will start going now.
Yeah.
So that is up to 200 psi.
Okay.
It's got quite a lot to go. So at this point, you can see that starting to crease up, and on the top you see dents.
Yeah.
And you also get tight spots here. So what I'll do is start working on this area and the top with just in its current state. So I have 2 main hammers. A smallish one that has the end rounded off and polished, and
okay, just so it doesn't leaves less
marks.
Yeah.
And then I have sort of a nylon, bit bigger, bit softer. This is good for sort of pushing material.
Yeah.
And this is good for a bit more specific work.
Yeah.
And a bit more force when you need it.
Yeah.
So we can start working on that. At the moment, as long as it's fairly smooth, because when you get full pressure, we can do other things to help alleviate that fold.
Yeah. So you're just tapping around the outside of it.
Yeah, you basically hammer the high spots.
Yeah.
To try and spread it a bit. Also, where the seam is still quite high up, you can start to push that straight, but not too much. So that's still quite bad.
Yeah.
But we're nowhere near full pressure.
Full pressure, so it should pop out.
Yeah. More pressure.
More pressure.
It gets to this point where I can swap the hole and get a bit more leverage.
Okay. Okay.
So we're up to.
All right. So
400 psi.
400.
Yeah. And you can see it's starting to go.
Yeah.
It's that now. If I keep.
Yeah.
I'll probably go all the way up to maximum pressure, which is about 750 psi.
750, and you got a bit of an extension in there as well.
Yeah, because it's only little. So if you watch it, you'll see it start to really swell here, and this will start going. And it might probably get another hole.
Yeah. Yeah, that's really round there now. Oh, yeah. Gone again, and there's one on the inside.
Yep. So,
there again, and there's one on the inside there.
Yep. Or is it running down?
No, it's gone out there, I think. I saw it was like a little gush.
You have to compensate for the expanding of the metal.
Yeah.
And also the angle of the curve as well.
Yeah. Cool. No rolls, brilliant.
Rolls, welding, and now that's holding 600 psi.
It's been a bit of a battle, hasn't it? It's been a few, but
2 or 3.
Yeah, but it's there. I mean, it's almost there, isn't it, from what I can tell?
So what we have to do is, you can see if you look from the end, how this hasn't formed round.
Let's have a look so I can get a profile. Yeah, so it's still a bit V.
And we have a dent to solve there.
Yeah.
And there's always one on this shape at the top.
Yeah.
And then we have inside the corners to try and get around and make round. So this is the raw pumping. This is what I think a lot of people don't realise about hydroforming, is that half the thing is pumping it up, and the other half is using the hammer to actually make it go as round as possible.
Yeah, so it's not as simple as, just fill it with water, pump it up.
No. Finishing is in the hammering, and that can take quite a long time.
Yeah.
So I usually start off around the outside outside seam. So that, again, that's got about 600 psi in it, and you're using the pressure inside to... The pressure inside makes it want to go round.
Yep.
So you're using the hammer to sort of help between it to go round.
Yeah.
If you can see that general shape.
I can just feel it. It's a bit ridged there. You can feel it.
Quite pointy.
Yeah. So. It's really difficult to Yeah, you can see there's a bit of a V there.
So what you do is hammer along the fold.
Yeah.
So I'll just do the header at first, and you can use your finger to feel for hot spots. So if you run it along, you can feel where it might need a bit more done.
Yeah, a bit there maybe.
Yeah.
And there.
So what that's done is got rid of the fold.
Yeah.
So I need to do the other side. So there might still be little bits. But the next thing is, once you kind of got rid of the fold, it's still quite pointy at the seam.
Yeah.
So that's when you start hammering straight on the seam, straight down, and it will kind of go round.
Right, okay.
So that's got it pretty round, and then of course you can feel along for any little lumps.
Yeah.
So there's a little bit along there. You can
Bit
feel
there as well.
Yeah.
So yeah, before it was sort of quite V'd here. It's difficult to show on the camera, but you can see how it's rounded.
This is how it starts.
Yeah.
That's a squashed shape.
Yeah, and now it comes down and it's just starting to round up quite nicely now. So working this side, then that side, and then you've hammered it actually down the seam itself just to push it in. Yeah.
So also what you'll find is where the belly section joins the baffle cone, that always wants to stay oval. You have to work quite a bit on the outer radius here. In effect, it has too much metal in that area, which is what causes the ripping here. So what we have to do is try and spread that out.
Yeah.
And the pressure inside actually will stretch it a little bit, and that's what helps fill out the dents. But at the moment I'm just working this seam, and then we'll work on that. And this is where the big soft
I could feel there was a dip there before, and you've pushed this.
Yeah.
It's almost prouder here, and you've pushed that down, and it's now flatter.
You're helping it along. This is where the soft hammer helps to push material. And it's still quite narrow.
Yeah.
But quite wide, so it's quite oval. So what you can do is basically hammer that straight in. So you'll always have the sacrificial butt at the end will always be oval, but that's where you cut off for the tailpipe.
Yeah.
But you still have to hammer it to...
Yeah, to get it somewhere near.
On long outer curves end up with dents. Some pipes are easier than others, so we have quite a good one here. So I could just hammer the high spots and that will spread it out, but what I find works quite well is to drop the pressure out, and in effect you make the dent worse. So you drop the pressure out and then you make the dent worse. So the idea now that dent is deeper, but it's hopefully more spread out.
Yeah, and it's going to form back up uniformly. Do you know what? I never would have figured that out.
It's only from doing a lot of them and trying different things and figuring out. So there still might be a mark, but it'll be better than it was. So let's try pumping it up. I'll pump it up now, and there'll still be a dent, but I will then hammer it smooth. Yeah. And hopefully,
see it going down there.
You'll see it improve.
No pressure, or lots of pressure.
Lots of pressure.
Yeah, so you can see it popping out here.
That's 800 psi in it.
Yeah.
But what that means is then I can
it's not. It went down loads
it's not
there.
A ripple, yeah.
Yeah.
So again, you hammer the high spots around it, and it will push. It sort of. So that's not far
it's
off.
loads better, isn't it? Because that was like quite pronounced before.
So again, you still have to work where the baffle meets the belly to try and sort of...
So this is quite a problem area of...
Yeah, this wants to remain quite narrow.
Yeah.
So to get this out wide, you have to push this in.
Yeah, and that's what's causing that to go down, isn't it? Is it's pinching in, I guess.
Also trying to get that, what would on a cone pipe, that would be a sharp angle.
Yeah.
It's always very hard to get. The pressure simply can't push it. But you get it as good as you can.
It's loads better than what it was.
So that's the outer seam done.
Cool.
No, I've got to do this top bit, so another dent to do there.
Yeah.
And then this curve here. So we've got the outer seam done.
Yep.
And the top seam on the main belly. So there's still a couple of little marks, but really nothing important. So what we have to do now is smooth up some of these ripples on the curve.
Yep.
And then we will work on the inner seam.
So you've just literally flattened all that down.
So there was about 3 dents along here, and I've tried to make one smooth big one. Yeah. To stretch the metal and hopefully make it a bit easier to come out.
It all come out together.
Dave's doing the pumping.
I'll do a bit of pumping.
Now the pressure goes up. It's up to about 700-800, and that starts to push it out. And now with the pressure in, I'll start hammering at high spots.
Greasing it as it.
That's sharp. There's still a dip, but I'm working. So when you're hammering this, what you're still doing is kind of it's flattening it almost. And when the ripples are gone, then you work on the seam, and that will bring it up and more round. So you try and get the ripples out first, and then you do the inner seam.
Cool. Cool, so fully inflated.
And this is full of water, so we have to get rid of it again.
Nope. Very nice.
That's one end.
Done.
There you go.
Brilliant. Voila.
Next job is to grind the seam back a little.
Okay. Is that angle grinder?
Yeah.
Yeah. Outside?
Yes.
Yes.
I've learnt my lesson.
Finished, well not quite finished, but nearly finished pipe. It's looking very nice. Nice and smooth. Martin's just going to flatten down some of his welds now, which I think look good anyway. So.
Yeah, a bit smoother.
Voila. Very nice. We say, so I guess you're going to chop it.
Trim the ends.
Trim the ends.
I chop it there.
Yeah.
And there.
Yeah.
That's the only cuts I do.
Yeah.
Rotate. I have to set this joint on the bike.
Yeah.
And then put the mounting point on, and then the tailpipe and spring loops and the manifold. Yeah, that's it.
That's it. How long we've been so far this afternoon? Probably about, what, 3 or 4 hours?
Yeah, about 3 or 4 hours. The next step is to trim to your scribe mark.
See if we can camera. Yeah, you can just see that there. So it's just tin snips.
Trying to be accurate, because you can tidy the end up on the bench grinder in a minute.
Oh, I'll just film on the carpet then.
There you go.
Yeah. Have you got a mark for that, have you?
No. The thing is, because this is tapered,
yeah,
I generally just trim it till it fits the tailpipe.
Ah, okay.
The penetration of the weld is obviously quite good.
Yeah.
Because, in fact, you can see it on the inside there.
It's not going to go there, is it?
It's hard to cut through. Let's try that. So again, you see it's slightly oval.
Yeah.
So I get my trusty hammer. There you go.
Yeah.
So that's quite a nice fit. That'll weld really well. That's the ends trimmed. Next step is to section it, and this has one cut here.
Yeah.
And one cut here. The first cut is 90 from the end.
Okay.
So I just mark that with pencil and
eyeball action.
Yeah. So that's the header section. And in fact, what this will do, if you're looking from the rider's perspective, is that will be at an angle. Yeah. And in effect, what I'll do is push the
pipes in a bit
inwards to
right,
tuck it in from the fairing.
Ah, cool.
So again, 130mm. So you put that on the end, 30.
You never have enough Jubilee clips. Ah, that's a top tip.
and that slides down. Get the angle about, you know, perpendicular to the direction. Back cut, I usually just start with a hacksaw enough to make a hole to fit a jigsaw in, and then run down the line with a jigsaw. That should do.
Yeah, I see. So you got a little hole.
Mm-hmm.
Yeah.
Oval.
Yeah.
But again, when you weld them together, I usually sort of squish that
Squish,
way.
yeah.
Squish that
You're
way.
same with cones.
So what I have to do now is tidy up these ends.
Yeah.
So that when that's rotated to its position, it's a nice fit.
Yeah. Sockets, eh?
Yeah, they're all the
Good for putting bearings in and all.
Yes.
Yeah.
And that slides in.
Nice tight fit.
So this is where we set the rotation of the header, determines almost the height of the rest of the chamber. But the more this is turned,
Yeah.
the
I
lower.
do it with cones.
Yeah.
You almost have too much angle on it, and you just rotate it until it gets about right.
That's it.
Yeah.
Got it. So what I need is a header experience. I want that about 10 mil below the frame. Right there.
Yeah.
So mark that. Pull that out. I will tack this and then just double check. You can see how that
Fits.
fits pretty
Yeah, it
good.
just sits under there. Sits there.
And there's your mounting point, which will go on under
Oh,
there.
I see. Yeah.
We've got to make the tailpipe,
Yep.
which needs a bend in it, and I've got my trusty plumber's pipe bending tool. I need about 29 degrees, so I'll aim for about 27 because that's already angled down. So I have to put the tube on.
Oh, yep. What's that? A fork tube?
Yeah,
Yeah.
CRM 254. There you go. So that's bent.
Yeah, that's nice. That. Cool, then.
So this laser cut flange
Ah, right.
to
Yeah.
suit Tiger silencers.
Okay. So the Tiger you tend to go with.
Yeah, and that line, I know that top hole
Yeah.
lines up with the inner of the curve.
Eyeballed again. Technical tap.
And see how that lines up. So you can see that that has to be bent in a little bit.
Yeah.
It's a bit more there. And just hammer that a little bit. In real life,
That's your reference because it's big sprocket, big, so it's actually further. So
Yeah.
this is kind of a. If it's just touching that, then I've got plenty of
You know
clearance.
it's gonna
Yeah.
line. And that usually I put a little bit facing back, and then I have to check that that's straight. So that's pretty much ready to go. So that's the mounting tacked on,
Cool.
and then this needs a little bit of back support. So that will come across like that. Okay.
Oh, I see.
Line. Cut that off.
Cool. That's just saying a bit of triangulation.
Yeah. Yeah.
So
So to work out the position of the spring loops, you can see there's the spring, and then you merely add sort of 6, 8, 10 mil, make a mark where you want it to go. Now I use my little carbon fibre stick just to check the distance to the swing on.
Yeah.
When I'm doing both pipes, I can rest that across.
Yeah, just to eyeball it to get the right
to the frame.
Yeah.
Also use that to get the other side to the right
distance
away.
Cool. So how old do you say that bit of cardboard was?
So I've used this template. This will be a gusset over the tailpipe joint, and this is about 20 years old.
Cool.
And it's been used for hundreds of pipes. So we just get a bit of scrap steel.
Don't lose it.
Mark the shape out. Well, it's an exact shape, so you know I'll never make one the same shape. Tin snip that out. Welding the gusset on. I sort of bend this a little bit just to fit across the joint.
Yeah.
Generally put a bit more on the chamber side because this is quite thick wall steel, so I know the tailpipe is quite strong. But it's more to support the thin bit of the chamber this side, so you kind of bias it that way a little bit. You can just tweak that to its fair fit.
Oily rag, just makes it 1,000 times better.
Right, so that's one weld done on the gusset, and then you see.
So the finished article.
Finished article, and that's obviously the manifold that will be bolted onto the cylinder. That slides on, just little ears.
Yeah. So it's all
spring to spring. I've got one in my hand.
Cool.
And
that's it.
That bracket's nice and beefed up over the joint.
Nice, isn't it? There you go. Cheers, Martin. Okay, thanks for having us over, Martin. It's been really interesting. I've learned a lot, and it's really, the pipe looks amazing, so I really have appreciated it.
It's been a pleasure, and hopefully people can have a go themselves, maybe. Also, I think I can show people that actually you don't need a lot of expensive equipment. A lot of the tools I use are quite cheap, easy to get hold of, and just have a go. I think that's how I started. If
anyone's interested, Martin said he does some porting, so maybe do a porting video. Let us know in the comments if that's something you'd like to see. Yeah, thanks again for watching. If you're liking it, please give us a like, subscribe. Look at a couple of the videos I'm going to put up in the corner now. So catch you next time.